Hi, so this is Charles and I am Aurele, and today we are presenting our final neural language processing project. So actually we did spend so much time on this project. Like we had so many issues, especially on the translation and other issue on the server that we couldn't use strong models. So that's why thanks to Thales, which is partner of this another project, we could run some GPU to like very strong GPU like RTX 6000 Blackwell edition to in order to run some very strong models. So through this project, you could see that we really could try some very awesome project models, and actually we quite had some very interesting results. So on the so yes, first for the data translation and everything, the main issue is that it was very hard to translate because either the model were too soft, even the big one like maybe 10 gigabytes is still a little bit soft, and it's mostly for English. So even when you're trying to translate it, it's still some words no corrected, only corrected, but still in French some words just convert to English like for no reason at all, and especially for um, some like link words. Also, that the original text translation was pretty bad. We could see that some of the words were like literally translated. For example, impossible de déclarer un sinistre transfers to impossible to declare online disaster, which doesn't make any sense. Anyway, so this is everything we've been trying to do. We used T5 base grammar correction. So T is for T5 text to text transformer, and this is all the best results we could have for some quotes, but it takes much time and um, very hard to do.
And so next we're going to talk about sentiment analysis. So we turn star ratings into 3 sentiment classes, which is a simple idea, but the interesting thing is what the distribution tells us. So we see here that people almost never give a 3-star review. They either love it or hate it, and that polarization is a real insight about how people evaluate their insurer. Then we also have LDA, who found 8 recurring topics automatically with no labels, and the result is striking. 90% of all reviews are either about price or the mobile app. Claims cancellations and customer service are barely mentioned, and this really tells us what French insurance customers apparently care about. So for the embeddings, this is where it gets genuinely interesting. So Word2Vec learns what words mean by looking at what they appear next to and generating vectors. When we train it on insurance reviews, it actually learns domain-specific associations that have nothing to do with general English. So the model figured out completely on its own that claims and accidents are emotionally heavy concepts in this corpus. Then, with the UMAP, we collapsed the 300-dimensional word space down to 2 dimensions. And you can literally see claim and accident sitting isolated on the left, far from everything positive. Service sits exactly between good and bad because customers never say service without immediately judging it. The geometry of the word space is telling us something real about the data.
Okay, so for the supervised model, I'm sorry we've been going very fast because in 5 minutes we cannot summarize everything we've been through, but you can see the slides that we're showing right now, and you can just pause and play and just follow it. So, but about the model that we did, we actually we do the classical TF-EDF one. So in order to just look at the frequency of the words, and depending on the frequency of the words in every document, a little bit of math over here. You can see again, you can look at our first project. We dive into this much deeper than this, but this is just a cool insight of everything with it, how it works. And so the idea is that once we've done this, we tried classical machine learning, and just like logistic regressions, linear SVC, or just naive Bayes. And here are some results. We can see that the accuracy of the logistic regressions comes at the top, which is pretty interesting compared to the other one, like linear SVC or an FBI, which still a little bit around 80, with a F1 loss to 75 to 77. And yeah, that's pretty easy. About the embedding layer in PyTorch, maybe Charles, do you have some words about this one? Or I can pursue it, but don't hesitate to interrupt me. So this is like how we trying to actually have a much deeper embedding models. Like, so we stack multiple layers and just doing like, we first like convolutional neural network, convolution neural networks in order to try and, even though it's text interesting, it's interesting to see it as a picture point of view. And with activation layers like ReLU, dropout, linear, blah, 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 blah. Everything is very explained in the code, but the idea is that here you can see that the model still learns, but at some point the validation loss just not very decrease at all, a little bit increasing actually, so it's not that very good. Also, maybe we can do the demo right now, or we can just dive a little bit deeper in the project. It's very tough, very hard to summarize in just a few minutes. But for the demo, so here, this is our application over here. Maybe Charles, you can just...
So now we can see the app we built. So we can type a clearly positive review, and it gives us a prediction on the sentiment of the review.
Yes. Here you can just run it, and here we have someone, and yes.
So we predict a positive label with 78% confidence.
Yes, so actually you can see that the prediction is instant, but it actually works in real life. It's just that we couldn't run the model and do the video at the same time. So, but here this is actually one of the results that we actually got. So here we give a positive in review, and it gives us some very good grades. So quite happy, and we also have like a summary on like the different insurance, all the things, explanation, information, right? And this is where we also put our model comparison, because this is something that it is very interesting to compare all the models that we've run thanks to our strong GPUs. So we tried Mistral with 7 billion parameters, and this comes at the top, but of course it's like, I think it's maybe 15 gigabytes of or a little bit higher of memory, and these are all other models that we actually tried, and yeah, I mean, that's it. If you have anything to say about the error, Charles, or
well, the confusion matrix shows that the prediction is actually pretty accurate. It stays in what we were expecting, so it's not like 100% accurate, but given the models we're using, it's actually pretty good.
But especially, I think, of course, we can see the neutral is a little bit struggling compared to the others.
Yes, because of how scarce the data is.
Yeah, the data is not very well, but yeah. Okay, I think it's pretty it. Maybe we could stop the video right now. We hope you really enjoyed the video. I mean, we really enjoy work on this project, and we really wish you a great health and everything for the next future. And we are very grateful for this semester with you.
Thank you very much.
Yes, thank you very much. Bye.
Bye.